Hey everyone, my name is Jenny Mann, a solutions architect and developer advocate. Today we're going to talk about streaming SQL. What is streaming SQL? First of all, let's understand what streaming means in this context. I find this guide at materialize.com explain it really well. Streaming refers to message brokers like Kafka, Kinesis, or Pulsar that handle data as a continuous stream of events or messages. Now, traditional SQL runs on a database, while streaming SQL runs on streams of live data. A primary difference between streaming SQL and traditional SQL is point in time versus continuous. Running a SQL query on a traditional database returns a static set of results from a single point in time. Let's say you're calculating a total sum from a bunch of invoices. You may run a SQL query like this one. Now with streaming SQL, you could run the exact query above and get a point-in-time answer. Suppose your list of invoices keep growing. The total amount would then be based on changing data. If you're just getting a static total, it would probably be constantly outdated. But if your invoices table captures real-time data that is constantly getting updated and ingested, then streaming SQL will always get you an updated total every time a new event comes in. So that instead of outdated data from a single point in time, with streaming SQL, you could run the exact same query on a stream of real-time data and get a point-in-time answer. There are a few streaming SQL solutions in the market. Today, I'm going to show you how to use one of them to apply streaming SQL to a simple dataset. The solution we'll be using today is S3Flow. I'm going to show you how to transform streaming data with SQL using S3Flow. There are a lot of use cases for that, including data cleansing, data mapping, data filtering, and data aggregation. For example, you may want to filter your data on a certain column, apply certain calculations to your source data, or aggregate data from multiple sources before the data arrive at your destination. In this tutorial, I'm going to show you how to use S3Flow to achieve that with a simple SQL statement. Suppose you have a table of employees with their names, address, and region they're in, and you want to filter by region and derive a target collection where only employees in the US are included. Suppose this is the end result you want in your destination. In Flow, you would navigate to the Collections page, click New Transformation. This brings up a pop-up window to derive a new collection. From here, there are just 3 simple steps. Select your source collection employees, pick a language, we're demoing SQL in this tutorial, and then give your derived collection a name, then click Proceed to GitPod. This opens up GitPod in another tab where an environment is already set up for you. GitPod is free to use. We integrate with GitPod in order to let users leverage the full capabilities of SQLite. GitPod is basically an online IDE that provides a complete development environment that can be accessed through your web browser, with all the necessary tools and dependencies pre-installed. In GitPod, navigate to your flow.yaml file in your workspace folder, which holds the specs of your derivation. You would want to update the specs to include the properties you want to see in your derivation. For our example, we'll add our database name columns, employee ID, last name, first name, address, and region. You want to enter here the name of the column you want to key on, in our case, employee ID. Under derivation, this is where you can set up migrations. If needed, you can use migrations to create our Alta tables that your derivation will use. But for our simple example, we won't be needing that. If you're interested in how to use migrations, this other video we've created demonstrates that. For our example, we'll just replace this with brackets so our flow.yaml won't be looking for the file. Similarly, for Lambda, you can put SQL statements to transform your source collection inside this Lambda file. Here are some examples of fields you can leverage. For our scenario, it'll just be a simple select statement filtering on region. So we'll just put it right here instead of referencing a separate Lambda file. Now you can run a preview to see the results live. It looks good, so I'm just going to stop the preview. Now to materialize it to a target location and see the results there, we'll run the flowctl catalog publish command to publish this derivation. It'll ask us to type the letter Y to confirm. Now publish successful. Let's go back to the Flow UI. Now we see here the new derived collection. To create materialization off of it, navigate to Materializations, click New Materialization. We'll use Google Sheets today, but you can also materialize your data to any of these destinations. Let's pick a Google Sheet connection I already have here. In the Available Collections dropdown, you want to pick your derived collection, SQL Demo. Before we hit Next, I'm just going to grab my Google Sheet URL from the endpoint config so that we can check the results later. Click Next, save and publish. Success. Now let's check our Google Sheet. I'm going to go to the SQL Demo tab. Now the only reason you're seeing many other tabs here is because I also used this sheet for other materializations. Anyway, you can now see the employees from the US region only. If you would like a deeper dive in streaming SQL and want to see another example where we show a stateful transform with migrations, check out this other video demo here. Thanks for watching. Subscribe to this channel for upcoming content on how to start or build a career in tech, how to automate using low-code RPA, how to build real-time low-code data pipelines, and other tech content.